Good everyone, welcome to Tutors. On today's episode, we are going to be discussing magnetic method and the qualitative interpretation of magnetic data. So, the very first video, we're going to discuss how to find the half weight of a magnetic anomaly, magnetic residual anomaly, how to find the half weight of a magnetic anomaly. Okay, for example, given that we plot a magnetic data where we have our data. Let me use something like this. Where we have our our nanotesla in the y-axis and our horizontal distance on the x-axis. Okay, and let's say we have a scale of 10, 20. Yes, 10, 20, 30. We have 40, and here we have 10, 20, 30, and 40. Here we also have 10, okay, minus 10, minus 10, minus, 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 minus 10, sorry, this is 10, here is 20, here is 30, and here is 40. Good. So we're doing half weight. Now just imagine that the graph that we plot looks like something like this. Can you see something like this? So for us to look for the half weight, we have to first find the amplitude. Yes, 50, yes, 50. And find the what? Half amplitude of this magnetic anomaly. So if you look at it, to find your half amplitude, the half of this anomaly, half amplitude is equals to the peak, right, minus the lowest over 2. Peak minus lowest. What is the peak? The highest reading of this magnetic data. And you can see that the highest here is at what? At 0, right? Highest is at 0. So we have 0 minus, and here is middle between 50 and 60. So that's like minus 55, right? 0 minus what? 55 divided by 2. And what would that give us? That would give us 22, 2 here, 27.5. 27.5. So what would 27.5 be? Around this place, like almost this place. So this is where we have our what? Our half amplitude. This point here. So you're going to rule a straight line. So we have our half amplitude. Okay, good. But now from here we cannot just say that that's where our half amplitude is. The next thing that we need to do is to find the half width for this magnetic anomaly. So what are you going to do next? You can see we extended the line from the vertical axis of minus 27.5, right? From 0 to this point, 27.5. We're going to extend it at this edge, we're going to extend it to the x-axis vertically with your ruler. Extend this to the x-axis vertically with your ruler. So here we'll turn to x1, here will be what? X2. Okay? So here is minus 20, here is minus 30. So here is minus, here is at the middle, and so our x1 here will be what? Minus what? 25. And here will be 20 and 30. Here x2 because what? 25. So our half width formula is giving us x2 minus x1 over 2. Our x2 is equals to plus 25 minus our x1, which is equals to negative what? 25 divided by what? 2. So x equals to 25 plus 25 over 2, and that's what? 50 over 2, and that's 25. So x half is equals to what? 25. Good. Although we've finalized some things, we've gotten our x half of this magnetic anomaly data. but that is not what we have been told. So sometimes they tell you to find the estimate, how to get your x half, so your half width. But we are using half width method to estimate the depth. Now I want to get the depth where that mineral or metallic ore is located in the subsurface. The depth. Let's say this is the surface, then we're going to, quantitative is all about like having an estimate, not really exact, having an estimate. So we want to find this depth. So there are assumptions of the kind of shape this ore could be. It could be a cylinder, it could be a sphere. So most time we use all these geometrical plane shapes. So if it's a cylinder, we'll say z is equals to, if we assume that it's a cylinder, 1.3 x half. Okay, so x half is equals to your x half is your half width. That's on that word, you know that x half. Okay, but if we assume that it's a sphere, it will be z is equals to 2.5 what x half. So now let us, you write in your book that assume the geometry is a sphere. Assume the geometry is a sphere. Is a what? Sphere. So since we're assuming that the geometry is a sphere, so we say z is equals to 2.5 times x half, which is what? 25, right? And what would that give us? Here will be 50, here will be 12.5, and that will be 37.5 meter. Okay, so that is how to get it. So you can try it in your own table to get the answer and comment in the comment section if the assumption is the geometry, if the assumption of the geometry is a cylinder. Thank you.